Okay, hello. So this is where we left off yesterday on question number 6. So the question asks, which trend is most likely displayed to the right? So if you look to the right on this chart, I want you to go ahead and pause and then answer the question. That way, when we review it, you can see if you answered it correctly. So go ahead and pause the video now, please. Okay, well, hopefully you paused it. Well, to go over this trend, if you look at it, one of the main things I think is easiest or best thing to do is just look at which one is the highest on there. So here I see that helium is the greatest. Then the second greatest, I know it will be neon, then argon. I notice that all these three are noble gases. So I know whatever trend that we're looking for, the noble gases have a very large amount of it, or where helium would be the one with the most of it. So let's look at atomic radius. We're going to go through each one of these. Atomic radius, which is the size of an atom. If we scroll up to the periodic table, oops, there you go. For ours, radius was down here by francium. So that means francium actually has the largest radius. And we know the trend increases as we go down the periodic table to the left. Opposite, we would have helium. So helium actually has the smallest radius. So it's not helium. Well, it's not radius. So, oops. It's all loading still. So it is not the atomic radius because helium is the smallest. Okay, what about ionic radius? Ionic radiuses are the size of an ions. Are any of these ions? Ions are when they have like a plus or minus charge. Like if lithium down here had a plus charge, right? Or oxygen had like a -2 charge. Yeah, none of these are ions. So B is out because there's no ions. Now let's look at ionization energy. Ionization energy is the amount of energy required to remove an electron. And remember, ionization energy is E for energy. So Ne is on this side, where you see where it says ionization energy. And here I have circled helium. So that means helium has the highest ionization energy. And I know that trend increases as we go to the right and upwards. So that means helium could have the greatest ionization energy. So maybe that one's a maybe. So let's go ahead and put a little question mark. Now, reactivity, it's just basically how much or the degree at which an atom will react with another atom or another compound or substance. So does helium react? Let's look at our trends. So I have R for reactivity, which is for metals. So helium is not a metal. Helium is a gas, so it's not there. And then for reactivity for nonmetals, we boxed in fluorine. So fluorine actually has the greatest reactivity. And then if you remember, your noble gases have zero reactivity. Why do they have zero reactivity? Well, it's because they're happy the way they are. They have their full valence shell complete, that they're not going to attract or react with anything else because they're unreactive. So this one's out because they're unreactive. And electronegativity, it's how much they want to attract extra electrons. Going back to the periodic table, electronegativity, we have it circled in purple, which would be fluorine. Fluorine is the element that has the greatest electronegativity, sorry. Main reason why, well, it's because it just needs one more valence electron to have its full outer shell complete, because it has 7 valence electrons right now. To have it complete, it needs 8, so it just needs one more. And because it's very, very attracted to it, because there's only 2 energy levels, meaning from the distance from the nucleus to the valence electron shell, it's very, very close. So they're very attracted to each other. Remember, the closer you are, the more attracted you are. The farther you are, the less attracted. So they're very, very attracted to each other right now. and it has a high effective nuclear charge. So all of your noble gases, because they do have their full complete valence shell, they have 0 electronegativity. They're not attracted to any more electrons. So helium would not have the most of it because helium is a noble gas. They should actually be on 0 down here at the chart. So this is not it. So 0 electronegativity. So the only answer it could be is ionization energy, which this is true because helium has the smallest distance from the nucleus to the valence shells, which it actually has no shielding. So for that reason, it's super, super attracted to those valence electrons. It's bringing them in very, very close. And then it has a high Zeph compared to hydrogen. So for that reason, it has the greatest ionization energy. All right, let's move on to the next question, which is when comparing fluorine to chlorine. So we're going to look at those two elements on the periodic table. We will use this light blue color. So if you look at the distance between fluorine and chlorine, or where they are located at, I see that fluorine is here, chlorine is right below. I notice that both of them have a Zeph of 7, right? Because they're on the column. Columns go up and down, so it's the one that's on 7. But what I do notice is that fluorine is on energy level number 2 and chlorine is on energy level number 3. For that, well, let's go ahead and write that down and then we'll go ahead and explain. And they're both halogens. So let's go ahead and write that down. Oops. So when comparing fluorine to chlorine, well, both fluorine and chlorine are halogens, right? Because we highlighted them in yellow. They're halogens, and both have a Zeph of 7. Now, what is different is the amount of energy levels they have. So fluorine has I forgot the S, has 2 energy levels. And chlorine has only 3. Well, it has 3. Has 3. So that means because chlorine has more rings around the nucleus, it's more the valence electrons on chlorine are a lot more shielded compared to fluorine. So chlorine has more shielding. Where is it? Oh, we're comparing fluorine to chlorine. So fluorine has less shielding. We're going to write on the bottom, less shielding. So fluorine has less shielding, which would make the nucleus more attracted to the valence electrons. Which nucleus is more attracted to valence electrons. There you go. Let's look at question number 8. Why do they have 0 reactivity or electronegativity? Sorry. I'll put me here at the bottom. I think that's better. Let's use green. So your noble gases, those are the ones on the very last column of your periodic table. If you notice, I colored them here in blue. So all the noble gases are on column 8. And why do they have 0 reactivity and electronegativity? Well, because they have their full 8 valence shell, like they have their full shell completed. So they have the valence shell complete, which means they have their full 8 valence electrons, except for helium. Helium only has 2. And so that means because they're complete, they're happy the way they are, they don't want to react with anything. They're unreactive. So they're unreactive. They tend to be by themselves because they're happy with themselves. All right, let's look at question number 9. It says when an atom loses an electron, it becomes giving it a blank charge, so the atom gets a. So when an atom loses an electron, right? Let's say it loses an electron. It's losing one of the negative charges on there. So the overall charge would be positive. So giving it a positive charge. Well, let me write it in a different color. Giving it a positive charge. And I know the atoms that are positive, they're called cations. So when an atom loses an electron, it becomes a cation, giving it a positive charge, so the atom gets, so what happens because they lost an electron, there's less electron-electron repulsion, so they get smaller. The atom gets smaller. When an atom, now let's look at the next question. When an atom gains an electron, it becomes so opposite when it gets an electron. Now we're adding more negative charges. I know when they're negative, it's called an anion. So giving it a negative charge. So the atom actually gets bigger. Why does it get bigger? Well, there's more electron-electron repulsion. So let's look at question number 11. Okay, so 11. So we are looking for scandium, potassium, argon, and sulfur. Scandium with a +3 charge, potassium with a +1, argon and sulfur with a -2 charge. So if we look at the periodic table, I snipped it. Scandium, which is right here, scandium has a +2 charge. Let's double check. +3 charge. So it will lose this electron. Remember, we always lose the 4s first. This electron and this electron. So it would actually lose the 4s to the 3d1, and it would be isoelectronic with argon. Okay, so now we know that this one is in the place of argon. Right here. This one's in the place of argon. Now we look at potassium. Argon's in the place of argon, so that's one thing that we can do. Potassium with a +1 charge means it loses 1 electron. So potassium is right here. If it loses that 1 electron, it loses the 4s1 energy level. So that means that all that's left is it right here where argon's at. So it's still with argon. Now let's look at sulfur with a -2 charge. Now because it's -2, it gained 2 electrons. Oops. There it is. So sulfur is right here. And if we were to get 2 electrons, so 1, 2, now it is isoelectronic with argon as well. So it has the same charge. So all of them are at the same electron configuration as argon. But now we want to know which one would actually be the biggest if they're all isoelectronic with argon. Well, the one with the fewer amount of protons would be the biggest one. So scandium, because they're all on energy level 3, so it means they're all on row 3. They're all on row 3. And the one with less proton would have less pull on the nucleus, right? The less pull you have, the farther away those elements are. So if you look at scandium, scandium has 21 protons, potassium has 19, argon has 18, and sulfur has 16. Because sulfur has the fewer protons, meaning there's less protons to pull in those electrons, especially because now there's 2 more electrons, there's more electron-electron repulsion, so the atom actually got bigger. So the correct answer is D. Okay, so let's go ahead and look at question number 12. It's asking which has a greater ionization energy, oxygen or sulfur? I want you guys to go ahead and pause and write down your claim on which you believe has the greater ionization energy between oxygen and sulfur. Hopefully I'll pause. Okay, so, excuse me, looking at oxygen and sulfur, where they are on the periodic table, I see that oxygen is right here and sulfur is right here. So oxygen and sulfur, they're right next to each other on the same column. So both of them would have an effective nuclear charge of +6. If we're looking at the rows that they're on, oxygen is on 2 and sulfur is on row 3. That means oxygen has 2 energy levels where sulfur has 3. Let's go ahead and write that down. So if we were looking at them on the periodic table, or all this color, oxygen is about right here and sulfur is right below it. They both had an effective nuclear charge of 6. Oxygen was on energy level 2, sulfur was on energy level 3. This is where they are on the periodic table. So let's go ahead and state our claim. First, we have to remember the trend where ionization energy is located. Think of the E in energy. Oh, what happened here? So, ignore this part on top. Oh, I don't know what's going on. I know that when I write the word near, N-E-A-R, the E in energy is in this general trend. So this is where ionization energy increases by. It increases as we go to the right and up the periodic table. So ionization energy, E, energy, sorry, I have like a little, I don't know, itch in my throat. So whichever one's closer to the E, between oxygen and sulfur, which are right here, oxygen's here, sulfur's here, which one is closer to the E? Well, because oxygen's a little bit more up, it is the one that is closer. So oxygen has the greater ionization energy. So we're going to go ahead and write that. Oxygen has a, notice I'm going to be just literally copy what I wrote here, has a greater ionization energy. And then we're going to put than sulfur. We have to compare it to the other element. If you do not put than sulfur, you do not get the points. Oh my God, I'm so sorry. Now for our evidence. There are 3 things that we need to include in our evidence. Go ahead and pause and then type your answer in the chat, like in the Teams chat, even though you're watching this video. Tell me, what are the 3 things that we need to include in evidence? Go ahead and pause the video. So hopefully you paused. The 3 things that we need to include in the evidence is the ZEF, which is the effective nuclear charge, the energy levels, and your shielding. Sorry. So for the ZEF, which is your effective nuclear charge, I'm going to go ahead and zoom in a little bit. There you go. I'm going to write it a little bit more on top. That way we have more space to write everything else. Is what column they're on. The ZEF is the proton pulling power. So because I noticed that oxygen and sulfur were both on the same column, they both have an effective nuclear charge of 6. So you're going to write that. Both oxygen and sulfur have an effective nuclear charge. Oops. Charge of plus 6. There you go. Which the plus on the 6 is to represent the proton pulling power. Now let's talk about the energy levels, which is what row they are on, the period, right? Period. So periods go like that. So I see that one is on row 2, the other one's on row 3, which are the energy levels. So oxygen is on energy level 2, right? Because oxygen is here. It's on energy level 2, and sulfur has how many energy levels? Sulfur has 3. Oops. And sulfur has 3. Period. Oh, my oxygen has 2 energy levels and sulfur has 3. That would have been a better written sentence. All right, now let's talk about the shielding. So energy levels and shielding kind of go hand in hand, because the one that has more energy levels has more shielding. So oxygen, because it has less energy levels, right? Because 2 is less than 3. So oxygen has less shielding than sulfur. Period. Now let's move on to the reasoning. So yeah, it's very important that you guys remember to include these 3 things: the Zeph, energy levels, and shielding, so you can get your points. Now for reasoning, there is one particular thing that the reasoning asks for. If you know it, put your answer in the chat and pause the video. If you don't know it, you can just continue watching, and that thing is the definition. You need to know the definition of what the question is asking for, which the question is asking for about ionization energy. So you have to know the definition of that, which we've written it down a couple of times. Well, and we've actually gone over it quite a bit. We've written it down on our class notebook. We've written it down on this note here, on your notes when we were learning about it. So one thing you need to include is the definition, and then you have to explain because why, or what is the reason? What is the reason? Yeah. So definition. What is ionization energy? Ionization energy is the amount of energy required to remove a valence electron. I mean, if you put an electron, that's totally fine. But yeah, the amount of energy needed to remove an electron. That's what ionization energy is. So for atoms that have very little shielding and has a high effective nuclear charge, it is really, really hard to remove those electrons. Why? Because the attraction to the nucleus is very, very great. So let's go ahead and explain using that example. So because, I don't really like using the word because in the beginning of my sentence, so we're going to use therefore, be a little better with our grammar, or with our vocabulary, not grammar. So therefore, comma, okay? I hope you guys are, if I go too fast, just pause the video. Therefore, the valence electrons for oxygen are more attracted I'm going to move me up here, are more attracted to the nucleus. and more energy is required to remove them. Making the ionization energy greater. There you go. Period. Now, this is a good answer. If you talked about the shielding, like less shielding, the more attraction there is. As long as you talked about the attraction to the nucleus, you're going to get your 2 points for the because why. Or less attraction to the nucleus, depending on what the question's asking. Like, let's say which one had a less ionization energy, then you'll be talk about like how it's not as attracted. So here you would get a total of 8 points, which is the part for your FRQ, which all of this will be done through Elluminate. You know how usually I give you guys like a Teams assignment for the drawing and stuff? This one, it's going to be all typed in to Elluminate. Unless you guys want to write it down, you guys can send it to me privately, but for the most part, it will be typed in. All right, we're almost done. Let's look at question number 13. It says, state whether a physical or chemical change has occurred. Provide an explanation for your answer. Just to remind you guys can definitely pause if you need to. So on this one to the left, know that these are two different questions. Okay, that's one question. The one on the right is another one. And there's actually a little mistake on this one. There's supposed to be one drawn on here. For some reason, when I snipped it, it like disappeared. So there's another one there. Okay, so anyways, looking at just this left half, we're gonna label this one A. Looking at this half, can you guys tell me, is this a physical or chemical change? You can pause the video, put in your answer. That way you can check for yourself. Well, this is I can tell you yet. If you were to grab one of these molecules, right, and you're going to compare it to another molecule on the opposite end, are they the same? Do they look the same? No, right? They look completely different. Inside the atom or the molecules, there's two different ones now. So it actually changed. So this is a chemical change. Now, if we look at the one on the left, we're going to label this one B. I'll use a different color, one that's kind of close to it. We'll use pink. So if I were to grab, let's say, this molecule and this molecule, are they the same or are they different? Well, I see that they have been like rearranged a little bit. Like one of them is like 180 degrees. It's just like flipped, but it's exactly the same like inside, like the molecular structure of it. So because it's the same thing, this is a physical change. And in order for it to be the exact same, all you have to do is just turn it around. Kind of like just flip it over. All right. Now let's look at your last two questions. Last couple questions. So it says to list the following scenarios as physical or chemical changes. Remember, to determine whether they're physical or chemical, remember City Girls Like to Party, which is like color change, gas, light, precipitate, temperature change. Yeah. I also included pH and smell for you guys. Yeah. So if any of those have it, then yeah. All right. So pause the video, go ahead and answer them yourself, and then I will give you the answers just to make sure that you're right. So pause. Wait a little bit. All right. Now let's answer them. Hopefully you guys paused it. If you guys didn't, oh well. Too late. All right, water boiling. Is that a physical or chemical change? You guys should have answered a physical change because it is the same thing. The water inside the pot and the water vapor, it's still water. It's still H2O, just in different states of matter. A hot pack. A hot pack is like a little package that you have and you crack it And when you crack it, two chemicals come together and they fuse. Eventually the temperature rises. So temperature increases. I know that temperature change is a chemical change. So a hot pack is chemical. There is also a thing called a cold pack, which is the same thing but opposite. When two chemicals, you crack it, two chemicals fuse together, they form, they react. Not only that, it's reacting in there, and then it gets cold. Kind of like mixing baking soda and vinegar. You guys probably don't notice, but if you do mix it, it gets slightly colder. That's an endothermic reaction. A rusty nail. I hope you guys answered that a nail rusting is a chemical change. It oxidizes with the oxygen outside. And last but not least, breaking a glow stick. If you were to have a glow stick and you kind of like crack it, you have chemicals come in together. Same thing like the hot pack and the cold pack. It fuses and they react, and that's how you get the luminescence of it. So this is a chemical change. Also, I want to give you guys a hint that if you did not do this exit ticket, I'm literally giving you the answers. So make sure that you get it done. And that is it. Today I will also release a like a quizzes or like a Kahoot of some sort that have questions that are definitely going to help you review for your test as well. All right, guys. When you are done watching this video, can you guys put a thumbs up on the Teams chat? This lets me know that you've completed it and watched it. Also, now that you have written everything down, you can go to your Teams page. I'm just going to use second period for example. Oops. And under the one that says 1021 Unit 3 Review, you click View Assignment. You're going to go ahead and paste your pictures onto here. That's part of the instructions. You look at it here, you're going to paste, you're going to upload this to the review assignment. You're going to take pictures and post it up there. But yeah, that is it. I hope you guys have a wonderful day. Don't forget to put a thumbs up in the chat.